So, Morgan, today we're on 6-3 doing law of sines and law of cosines. So, when you were in geometry and doing laws of triangles, you often use SOHCAHTOA, but those can only be used in right triangles. So, of course, not all triangles are right triangles, so we have to have some mechanism to solve for the sides and angles of a triangle. So, law of sines and law of cosines gives us that opportunity, but they each kind of have their own special circumstances when they can be used and when they cannot be used. So let's do law of sines first. I think you guys did this in IM too, but we're going to do it again. So law of sines is based on the idea that there is a proportional relationship between the sides and angles of a triangle. So whenever you see the angles of a triangle, they will always be in capital letters. The sides that are directly across from that angle is its coordinating side. So angle A goes with side A, angle B goes with side B, and angle C goes with side C. Sides are in lowercase, angles are in uppercase. Okay? And it's proportional. So what I mean by that is that the smallest angle of a triangle is always going to go with the smallest side. The middle size angle is always going to go with the medium length side, and the largest angle is always going to go with the hypotenuse. That proportion will always be true in any triangle. In fact, it's impossible to draw a triangle where that doesn't occur. So when you can use law of sines is if you have one of these pairs that you already know. So you can kind of think of it as if you were doing a science experiment, it's kind of your control group. You know that proportion, or you can calculate it. So you can kind of think of it that way as a control group. So usually those are going to be in angles that are angle side angle, because if you're given two of the angles, you can figure out the third, and then these two would be the pair. If they're angle angle side, again you have a coordinating side and angle, and if they are side side angle, same thing. You've got that pair that you can rely on. Okay? If you don't have those, that's when you would use law of cosine. Okay, so let's go down and we'll do one of those practice problems. So when it says solve the triangle, this means I need to know the length of all three sides and the measurement of all three angles. And what I do when I do this is I kind of draw myself a little chart, and I put my angles on one side and my sides on the other side. Okay? And then I fill in what I know. So for example, in this triangle, I know that angle A is 40. I know that angle B is 60. Can I calculate angle C? How? It has to add up to 180. So that's 100. So angle C must be 80 degrees. Okay? Which side do I have a measurement for, A, B, or C? A. And I would label your triangle before you do anything. So that is going to be the length of side A. Based on what I'm seeing, this should be my smallest pair. A should be my smallest, B should be the medium, and C should be the large. So we'll see if that works out that way when we calculate them. So what is the control pair that I can use? Right. A, not A and B, it has to be the same angle, same side. Letter has to be the same. Sine A over A, right. We know sine A over A. You can also flip this upside down. The proportion's the same. Okay, but we know that the sine of A, which is 40, divided by our A value is 4. So now we can just use that to calculate the others. So if you have, let's figure out B first. So my measurement of B is 60, and I'm trying to find side B. So when you have a proportion like that, how would you solve that? You would cross multiply. And so the easiest thing to do is you're going to multiply the pair that you have and divide by the pair that you don't have. By the value, part of the pair that you have. So this would be B equals 4 times sine 60 divided by sine 40. Okay? When you put that in your calculator, I always do the sine 60 first. You can definitely do 4 times sine 60. You have to put parentheses in and be careful about that. I just find it easier to put the sine 60 in first. So you're going to do sine of 60 times 4, and then I divide it. I put parentheses in before the denominator just to double check everything. Sine of 40, and you can round off to hundredths space, so that'd be 5.39-ish. Okay, so that'll be our measurement for B, 5.39. And since 60 degrees is bigger than 40, 5.39 is bigger than 4, so far we're doing okay as far as our proportions go. All right, so let's do that for side C, and I'm going to put it on pause while you do that. All right, so there's my proportion set up. So C would equal 4 sine 80 divided by sine 40, and that would give you about 6.13. So there's a couple ways you're going to be able to check this. First of all, do the small, medium, large kind of apply to both columns? Smallest, mediumest, and largest, right? The other way you could check that is do your sine of each of those numbers divided by the length, and you should come up with about the same number for each of those proportions. So if you did sine 40 divided by 4, it's about 0.1607. It's about 0.1607. If I did sine of 60 divided by 5.39, I get the same number. If I do sine 80 divided by 6.13, I get about the same number. So that proportion of that angle being, the sine of that angle being divided by the side should give me that same proportion every time. Then I know I did it right. Okay? Okay, so using our law of sines, I ended up with angle measurements of 35, 15, and 130, and side lengths of 3.74, 1.69, and 5. Is that what everybody got? Yeah. Okay. All right, let's go down to the bottom example because there's something a little different going on with that one. So I would again start with what I have. Make your chart. So I know that this is A, this is B, C side. So I know that A equals 3, B equals 2, and angle A equals 40. So the only control side I have is A, control pair I should say. But the difference is now I'm calculating for an angle, not for a side. So you're still going to set it up the same way. So you have sine of 40 over 3, that's my pair that I have, equals, and the only side I have to use right now is B. So what I'm figuring out is sine of B. Okay, so not the length of the side of B, but the actual angle size. So when I rewrite that, sine of B is going to equal, again, multiply and then divide. So 2 sine of 40 divided by 3. And if we calculate that, we get sine of 40 times 2 divided by 3 is about 0.42. When you're getting this ratio, I would take it out to 4 decimal places, so 4285. So that's not the measurement of the angle. That's the ratio. So it's actually the position on the unit circle is what it is. So if I do that, then I need to do second function sine 0.4285 and then enter. So that angle B is going to be about 25 degrees. And you can round it down to a whole number. It's fine. It's going to be about 25 degrees. Now, once you have that, now you can go back and calculate the angle, the remaining angle, which would be 180 minus 65, which is 115, and then calculate that C value the way you did the first two problems, which should be 4.23. Okay, so that is law of sines. you have to do inverse or second function sine. So here. What that 4.4285 represents is how high up the sine part of that function goes. When we get into actually putting triangles on a unit circle, you'll see what that actually means. But that's an actual height, is what that is. So you do a second function, or inverse, depending on your calculator, sine 0.4285. Okay? All right, so I'm going to do the law of cosines on a separate video, and then I'm going to merge them together. So when you get that, go about 11 minutes in, and the law of cosines notes will be on that, and that's due on Tuesday. Okay? Be on the same notes. All righty. Oh, one thing to throw in before I forget, your sine, that sine value, your inverse sine, always has to be between -1 and 1. What's the radius on a unit circle? 1. It has to be in between those two numbers. Okay? I'll explain more about that on Tuesday.